whilst there are some genuinely difficult things to do at GCSE Maths, most of the things that we call complex problems are due to the number of steps that you're having to carry out in order to solve the problem, and the fact that you may be using 2 or 3 different elements from different topics in order to solve the problem. The other complexity relates to the fact that the problems tend to be unique, and therefore you've got to look at them carefully and work out the steps yourself. You've got to apply some mathematical reasoning and logic to getting to the solution. So whilst the overall problem might be complex and difficult at first glance, the individual parts of mathematics you're going to have to use tend to be quite straightforward. So, for example, if you can work out the area of a rectangle or a circle or a triangle, you should be able to solve most of the problems that we're going to look at here. So let's have a look at a couple of problems that on the face of it look quite difficult, but in fact if you work through them carefully you'll see that the maths involved is quite straightforward. Our first example involves the volume of a sphere. So what is the volume of a sphere if we're given the surface area of 144 pi squared centimeters squared? So you're told one fact about an object and you're having to work out another fact. So the first thing we need to do here is find the formulae for the area of a sphere and the volume of a sphere. So here's the first piece of good news. Both of these pieces of information should be on your formula sheet. So get the formula sheet, look at the equations for the area of a sphere and the volume of a sphere. Of course, if you can learn and memorize these 2 equations, that will be really useful. Otherwise, rely upon the formula sheet. So the first thing we're going to do is to use the area formula to work out what the radius of the sphere should be. Because once we've got the radius of the sphere, we can work out the volume. So you see there we're having to take multiple steps to get to the end solution. And in this particular question, we're having to move backwards before we can move forwards. So the first thing we're going to do is take that formula for the area of the sphere and rearrange it so that R is the subject. So that's quite straightforward, isn't it? We divide the area by 4 pi, we get R squared on one side, we take the square root, we end up with R on one side, and the square root of A divided by 4 pi squared. So let's substitute the value that we have for the area in there, and we end up with an equation that is R is equal to the square root of 144 pi divided by 4 pi. If we do some simple cancellations there, we work out that's the square root of 36, which is 6. Now we can use this value in the formula for the volume of the sphere. So the volume of the sphere is 4 pi r cubed divided by 3. So if we take our value of r, which is 6, put it into that formula, we get 4 pi times 6 cubed divided by 3. We can either plug that straight into the calculator or do a little bit of cancelling, and we end up with a result there that is 288 pi centimeters cubed. So you see, to get to this result, we've worked backwards from the area of the sphere using the area equation, and then we've worked forwards using the volume equation. Nothing too tricky in there, it's just working out what steps we have to take and in which order we have to take them. There is another quicker, more of a shortcut way to work out this solution. If you look at the 2 equations, one for the area and one for the volume, and see how they are linked. How could you go straight from the area equation to the volume equation? If you can work that out, you'd be able to do this question a lot quicker, and I'll leave that one for you to figure out for yourselves. Let's look now at another example, also involving a sphere, but this time involving a mixed measure, the measure of density. And we're told in this question that we have a cricket ball, it weighs 160 grams, and we're told the circumference of the cricket ball is 22 centimeters. We're asked to work out what is its density. We're also told a value of pi to use of 22/7, so we can't ignore that, we have to use that value. To work out the density, we need the weight of the object, which we're given in the question, but we also need the volume. To work out the volume, we're going to need the radius of the cricket ball. We've already seen the equation for working out the volume in the previous example. So we'll take the circumference first, which is 22 centimeters, and we'll use that to work out the radius. So the circumference is 2 pi r, which means that the radius is the circumference divided by 2 pi. 2 times pi is 44 over 7, so our radius is 22 divided by 44 over 7. To divide by a fraction, what do? Remember, we turn the fraction upside down and multiply, so we end up with 22 times 7 divided by 44. Some quick cancelling will show you that the radius therefore is 7 divided by 2, 7 over 2. So now we have the radius of the cricket ball, we can work out the volume. We take our equation for the volume from our formula sheet, 4 pi r cubed over 3. We put in our value of 7 over 2 for the radius. We've also got a value of pi of 22 over 7. And if we put all those numbers in there, you see we get that particular equation, and if we work that through either on a calculator or by judicious cancelling, which we can do here, we end up with volume is equal to 539 over 3 centimeters cubed. We've gone through that calculation fairly quickly, so it was probably a good idea if you get yourself a pencil and paper and make sure you can do that kind of calculation with fractions and cubes and divisions and so on. It'll make your life easier in the long run if you can make sure you can do that, because usually in these questions you are given values that do cancel easily, so you're not ending up with very long decimal values to carry on in your calculations. The questions are all about the techniques rather than about working out the numbers. Okay, we're on the last leg now. We have the volume now of the cricket ball. We are given the mass or the weight in the question, and so all we need to know now is that density is weight divided by volume. It's weight per unit volume. So our weight is 160, our density is 539 over 3. We're going to divide by that volume, so to divide by that fraction we turn it upside down and multiply. So we get a value for our density of 160 times 3 over 539, which is 480 divided by 539 grams per cubic centimetre. So that's a value of slightly less than 1 gram per cubic centimetre. So each small part of a cricket ball is actually quite light. So we've seen in both these examples a complex problem isn't necessarily about dealing with very detailed numbers. It's about stringing together several pieces of mathematical knowledge and being able to work out a solution to a problem that requires you to know 2 or 3 things and to put them in the right order. It is absolutely imperative when working out these kind of questions that you write down every step that you take, because you are doing problems that involve multiple steps. You are more likely to make errors if you try and keep that information in your head. Write everything down, write it down logically, and write it down in as much detail as you possibly have time for.